Okay, today's lesson is simplifying radicals. And we're going to look first at just simplifying a radical, and then we'll throw in some variables with it. Okay? So first off, let's talk about radicals. It's, if I take, let's see, 6 squared, 6 to the power of 2, 6 squared equals 36, correct? Means 6 times 6, right? 6 times 6. All right, well, the square root, and this is kind of like an invisible 2 there, saying it's a square. The square root of 36 is 6. All right, so a radical, this is the radical. All right, so a radical is kind of like the inverse or the opposite of square, taking the square of something, of powers. Okay, so that's what we're going to be looking at and how to simplify them. I'm like, now you're like, well, I'm going to put in my calculator and get the answer. Well, that's all well and good. However, when you start in algebra, we start simplifying where you might have something that looks like this as your answer. Your calculator won't give you that, okay? So you have to learn how to do that. In geometry, especially geometry, you'll use these a lot. You'll be simplifying radicals a lot. All right, let's look at parts of a radical. All right, so the n, this, like on square root, they don't put it there, but it's understood that it's a square. This is the index. So for a radical without anything there, it's understood that the index is 2. If I was going to have a cubed root, they would put a 3. If it was a quad, you'd put a 4 or 5. All right, so whatever that index is going to be. All right, 2 is the only one where they don't write it. The little house, I call this the house. That's called the radical. And then what's inside the house is the radicand. Okay. All right, if there's no index, it's assumed that the index is 2. All right. All right, if a radical has more than one root, the radical sign indicates only the principal or positive root. All right, and we're only going to be dealing with the one roots listed. All right, first let's look at perfect squares. Now, perfect square would be like 36, because 36 is 6 times 6, right? If you can take the square root of something and there's not a remainder, that's a perfect square. So if you look at 1 times 1 is 1, and then 2 times 2 is 4, 3 times 3 is 9, and then look at the 4s. 4 times 4 is 16, then the 5s. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8, 64, 9 times 9, 81, 10 times 10, 100, 11 times 11, 121, 12 times 12, 144. All right, so that's just the first 12 perfect squares. You can go on and on, 12, 13, 14, all right? Those are squares, perfect squares. And we'll look at cubes later on. All right, so if you have a perfect square, then you're just going to answer it like square root of 81 is plus or minus 9, right? Because you can say 9 times 9 is 81, and negative 9 times negative 9 is 81. All right, square root of 484, is it a perfect square? Well, what do you think? Well, let's come back. Let's come back to that. All right, let's look at square root of 64. It's plus or minus 8, right? And like 121, we know that that's 11. So negative 5 times 11 is negative 55. Let's see, square root of 4, we know that that's 2. So 18's on the outside. It multiplies with that square root of 4. So square root of 4 is 2. So 18 times 2 is 36. Square root of 1 over 16. Well, that's the same thing. Square root of 1 is 1. Square root of 16 is 4. Square root of 9 over 100. That's a perfect square because the square root of 9 is 3. And the square root of 100 is 10. So 3/10. How about number 9? Perfect square? Yeah, 25 is. We know that's 5. And 49 we know is 7. All right, let's look at 256. Now, we only went to 11 here. To 12. What would 13 be? So 13 square would be 169. 14 square is 196. And 15 square is 225. And then 16 square is 256. Well, we know, okay, so that's a perfect square, right? 16 times 3, and that's 48. My pen don't want to write. 48. And 484, well, let's see if it's a perfect square or not. We got all the way up to, 16 here? So let's try 21. What's 21 times 21, or 21 squared? Well, that's 441, so we're close. Try 22 square. Well, 22 square. All right. These big numbers like that, you kind of have to play with them. Most of them, though, is going to be like square root of 13 and less, okay? 13 square and less. Those perfect squares. All right, find the largest perfect square that the radicand is divisible by. Break it down using the radical. Breaking down the radical using this number. Then take the square root of the perfect square and take it out of the radicand and leave the leftover under the radical symbol. All right, so let me show you what they're talking about. All right, so on step number 1, you're looking at the factors. Okay, you're looking at the factors of the radicand, the number inside the house. And you're seeing if any of those are a perfect square. All right, and factors are the numbers you multiply to get a number, right? So look at the 24. Factors of 24. Well, we know 4 times 6, right? And 4 is a perfect square, right? So what's the square root of 4? 2. So I'm going to put it outside the house. The 6, he's left over. He's part of the leftovers. So it's going to stay home. Okay? Now these are pretty easy since these are smaller and you can find the factors, but I'm going to show you a way later that if you can't find a perfect square, we'll go from there. All right, 48. Can you think of any right off? 16 times 3. 16 times 3. Well, 16 is a perfect square, so the square root of 16 is 4, so 3 stayed home. All right, let me show you, though, how to do this if you don't recognize a perfect square. All right, we're going to do it this way. So if I got square root of 48, I'm going to take 48, and I'm going to do a factor tree on it. All right, so 48 would be 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3, right? So here are all the factors broken down to prime numbers. So that's a factor tree. And there's all my prime numbers. So I'm going to, since this is a square root, I'm going to look at pairs. All right, so I got a pair of 2's. So the 2's got married and became 1. 2's got married and became 1. All right, 3 doesn't have anybody, so the 3 stays home. Okay, the 2, they multiply. 2 times 2 is 4. Okay, let's do 72 that way. All right, so 2 times 36. Well, we know 36 is a perfect square, 6 times 6, right? So I got a pair of 6's that came out as 1. They stay outside. 2 doesn't have anybody, so he stays home. All right. Let's look at 63. All right, so I know 2's not going to go in there evenly, so let's try 3. 3 times 21, which is 3 times 7. All right, these are all prime numbers. So I got a pair of 3's, and they come out as 1. 7 doesn't have anybody, so he stays home. And the 3 comes out. There's nothing out there to multiply with, so it goes to the front door. All right. You could have also broken this down to 9 times 7, is 63. Well, that's perfect square is 3, right? 7 stays home. 90. All right, this one we know we got the perfect square, 9 times 10. So square root of 9 is 3, right? So 3 comes out and 10 stays home. All right, let's try 175. All right, we know 25 times 7. Right, that's 175, right? Well, 25 is a perfect square. You got a pair of 5's come out, and 7 stayed home. Okay. And y'all, this just takes practice. Let's look at the next page. All right, 162. So let's do 2 times 81. Well, 81's a perfect square, 9 times 9, right? So a pair of 9's come out. 2 didn't have anybody, so it stays home. 245. Well, I can't think of a perfect square as a factor right off. So we know it's divisible by 5. So 5 will go into 24 4 times, and then, oh, but look at there. There's another perfect square. 49 is 7 times 7. All right, so there's your prime factors. I got a pair of 7's come out, and a little old 5 stays home. 5 doesn't have anybody. Okay, 343. Well, let's see. I either start off with 2 or 3. So let's see what 3 does. Will 3 go in there? 3 will go in there one time. 3 will go in there one time. That doesn't go evenly, does it? All right. So let's try 7. Okay, 7 will go into that 4 times. 28, 9, 30, so 63, so 9. Oh, there's your perfect square. 7 times 7. So now I got 3 7s, but only 2 can pair up for square root, right? And come out as 1. So 7, and the other 7 had to stay home. All right, 117. So let's try 7 won't go. 3, 9, 10, 11. Let's try 3. 3 times 3 is 9, 10, and then 3 we're going to 27 9 times. And then 3 will go into 39 13 times. So here's our prime factorization. I have a pair of 3s that get married, come out as 1, and then 13 stayed home. Okay. All right, so 28, it's 2 times 14. 14 is 2 times 7. So those are all prime numbers, right? So I got a pair of 2s that come out as 1. 2 comes out, 7 stays home. And let's try 450. All right, so we're gonna go 5 times 90, which is 5 times, and I'm always dividing by prime numbers, okay? 2, 3, 5, 7, all right. 5 will go into 90, 18 times, and then 18 is 2 times 9, and 9 is 3 times 3. So here's all our prime numbers, our prime factorization. All right, so look at here. I got a pair of 5s. They got married and come out as 1. I also have a pair of 3s. They got married and come out as 1. 2 stayed home. 5 times 3, well, now they're going to multiply, so I get 15. I put him at the front door. Okay. All right. Now, for perfect cubes, you're doing the exact same thing, but instead of pairing up to come out, they have to be in 3s to come out. So, but let's look at some perfect cubes. We don't use those as much. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And then 4 to the 3rd power is 64. 5 to the 3rd power is 125. 6 to the 3rd power is 216. And don't worry, I don't know these by heart either. I know these, and I know this one. But some of these others, so this was 1, 2, 3, 4, 5, 6. So now we're going to do 7. 7 to the 3rd power is 343. 8 to the 3rd power is 512. 9 to the 3rd power is 729. 10 to the 3rd power, that one I know, is 1,000. Now, when I get numbers up in here, past the 125, then I'm going to be breaking it down, doing the prime factorization tree. Okay? And plus factors If it's a 27's a factor, I won't know it until I do the factor tree, okay? Because I don't have all those memorized. If you have them memorized, awesome. Awesome, like 729. I would have broken it down, but I see right here that 729 is 9 to the third power. All right, so the cubed root, see how the index is now 3? The cubed root of 729 is, I can't say plus or minus, it's got to be positive 9, okay? 8, you say, well, 2 times 2 times 2. -1. I wish they didn't put these negatives on there because I really don't want to get into that, but just put the negative in front of whatever it is. All right, 343 was on our list. So we're going to put the negative and then 7. And then 1331. I bet you, what's 11 cubed? 1331. So this is 11. And 27, that was 3, right? So -3. So those were all perfect cubes. All right, so now we're going to simplify these non-perfect cubes. So we're going to have to break it down by prime factorization, okay? 2 times 20. It's 2 times 10. It's 2 times 5. So there's our prime factorization. Remember, we're doing cubed roots, so they have to be in triplets. So I got triplets come out as 1, it's 2, and then 5 stayed home. And oops, remember, put your little index of 3. 500, it would be 5 times 100, which is, oh man, which is 5 times, I was going to do 10 times 10, but let's do 5 times 20, which is 5 times 4, which is 2 times 2. So there's your prime factorization tree. I got a set of 3s. Well, a set of 3. Well, so I got 3 5s that come out as 1. And this 2 times 2, I don't have another 2, so they're going to have to stay home. And 2 times 2 is 4, right? So they stay home, and 5 comes outside. You know, if I don't have enough to come out, then I just multiply it back and put it in the house. Okay, 162. My hand's going to sleep, y'all. All right, so 2 times 81. And y'all know that's 9 times 9, which is 3 times 3. It's 3 times 3. So there's our boot. Don't forget that 2 sitting up there. So I got 1 set of 3s. 3 3s come out as 1 3. And I got a 2 and a 3 left over. So 2 times 3 is 6. Going to stay home. Put your index of 3. And then this 3 comes out. All right. And y'all, a way you can check it is whatever's on the outside, do it to that power. So 3 to the third power is 27, right? And 27 times 6 equals 162, okay? So if you take this, put it to the power, and then multiply it with what's on the inside, it should equal your radicand, if you've done it correctly. Because I want to show you, let's see. Let's look at this one up here. 15 to the square root of 2. So 15 square times your radicand, that's going to equal 450. Okay? So you could check your answers that way. All right, 16. It's 2 times 8. It's 2 times 4. It's 2 times 2. So I got 3 2's. Come out as 1. And 2 stayed home. I'm going to put that negative back in there with it. All right. 432. Ooh, these big numbers. That's 2 times 2, 6. And that's 2 times 108. 2 times 54. 2 times 27. And we know 27 is 3 times 3 times 3. Ooh, I got a big boot there. All right, so I got some 3's that come out as 1 3. And I got some 2's that come out as a single 2. And this little darling stays home. It's cubed root. 2 times 3 is 6. So let's check our answer. 6 to the 3rd power times 2 equals, so 6 to the 3rd power is 216 times 2 is 432. So we're good. All right, 54. All right, so let's do 3 times, let's see, 3, 11, 5, 24. So 3 times 18, which is 2 times 9, which is 3 times 3. So in my factored boot there, I've got 3 3's. So I got 3 that come out and 2 stayed home. I keep forgetting to put that index of 3, y'all. All right, 96. 3 times 32. And that'd be 2 times 16, which is 4 times 4, which is 2 times 2, and that's 2 times 2. So I always circle my factor boot there, okay, with all my prime numbers so I won't forget any. All right, so I got a set of 2's that come out, and then I got 2 2's, but I need another one, so I'm out of luck. So all of this stuff can't go in, so I'll go multiply. 3 times 2 is 6, and times 2 is 12. So 12 stays in the house, index is 3, and I only had a 2 that come out. So we'll check our answer. 2 to the 3rd power times 12 equals 8 times 12, which equals 96. So we're good. All right. And let's see, I got one more. I usually don't do all of them, but this one's a big one. All right, 875. Since we ended with a 5, I'm going to divide by 5. So 5 going there. 1, 7, 5. And let's see, let's do, I know 25 times 7, right? So let's pull out 5 times 5. So we got, there's my factor boot. So I got 3 5's that come out. So 5 cubed root of 7. Now it's got that negative, so we'll bring it out. All right, so negative 5 to the 3rd power is negative 125 times 7 equals negative 875. So we're good. Our answer checks out. So this answer is good. All right. let's go to that next sheet. I know you're going like, oh my God, Miss Lane. Well, we won't do all of these, but I just want to show you what it looks like when you throw a variable in there. All right, square roots with variables are also known as monomial square roots. It's because they got a variable with a number, right? Okay, just like numbers, variables can be simplified. If m is a multiple of 2, use the rule square root of a to the m power. Okay? And if m is not a multiple of 2, break it apart. Okay. All right, this would be a m divided by 2. Let's make this simple to understand. All right, so I'm looking at my exponent, and my index here is that invisible 2. So we're at square root, right? So if it's a square root, I'm going to look at it being divisible by 2. So it's 2 divisible by 2. Yes? And it's 1, right? So it's going to be x on the outside of the radical, it'd be x to the 1 power, invisible 1. Do I have any x's left over? No. So it's just that. There's nothing left. My radical's gone. The house blew up, blew away, because nobody was in it. All right, how about m? Can I divide it by 2? Yes. How many times? 3? Any left over? No. House blew up, went away. My answer's m to the 3rd power. All right, let's put a number with it. Okay, 9 is 3 times 3, right? That's a perfect square. So it comes out of the house. K to the squared. All right, so it's divisible by 2 one time, right? Because K times K. Did anything stay home? Nope. So the house blew up. All right, so your answer is 3K. All right, let's look at this one. 100 is a perfect square. 10 times 10, right? And then square, square. So we're going to come out and say 10x, y. House blew up and went away. Okay? It's just your exponent divided by 2. And that goes on the outside. If there's any remainder, it stays home. I want to get to one with a remainder here. Okay, let's look at this one. Y to the 5th power. All right, and look, it means y times y times y times y times y. All right, they paired up, come out. They come up, paired out. How many pairs? 2. So I got 2 pairs on the outside, 1 stayed home, right? So 5 divided by 2 is 2, with 1 left over. All right? And I wanted to show you this to show you why we're doing it like we are. All right, A's, I got A times A. B cubed is B times B times B. All right, so 2 divided by 2, I got 2 pairs, so 1 came out, right? I got 3 B's, so I'm going to take 2 of them. So I got A to the 1, B, I got 1 B, and then I got a B that has to stay home. Because 3 divided by 2 is 1 with a remainder of 1. Okay. How about this one? Divided by 2 is 1. Divided by 2 is 1 with a remainder of 1. And 4 divided by 2 is 2 with no remainder. So that's your answer. 144, perfect square, 12, right? Okay, for my K's, 3 divided by 2 is 1 with a remainder of 1. Uh, 196, let's break that one down. All right, so this would be 2 times 98, and that's 2 times 49, and that's 7 times 7, right? So I got a pair of 7s come out, and I got a pair of 2s come out as 1. 2 times 7 is 14. So nothing stayed home as far as the numbers go. All right, C's. I got 5 C's, so I got 2 pairs that come out. 5 divided by 2 is 2 with a remainder of 1. D's, 2 divided squared, it's squared, right? So 2 divided by 2 is 1 with no remainder. So this would be your answer. Okay. Let's do a few of these. This is all. Let's pick some big numbers so we can practice doing the little boot. Okay, 160 is going to be 16 times 10, right? And 16 is 4 times 4. And this is 2 times 5, right? So there's our, whoops, 2 times 2, almost. So here's our prime numbers. So I got a pair of 2's here, a pair of 2's here, and then I got 2 and a 5, all right? So 2 times 2 is 4, and 10 stayed home. And you could have said 16 is a perfect square, so the 4 come out, okay? All right, a to the 3rd power. So I had 1 pair and 1 stayed home. And b to the 6, how many pairs of 6? Pen won't write, y'all. Okay, so 6 divided by 2 is 3 with no remainder. So that would be your answer. And we can check our answer. What's 4 squared? 16, right? What's a squared? So we're doing a power to a power. 1 to 2 would be 2. And then what's b cubed squared? Be b6, right? Okay, times whatever's on the inside. So 16 times 10 is 160. A squared times a is a cubed, and then b6. Well, that's what we had, right? So it checked out. And let's look at this one. 108 is 2 times 54, which is 6 times 9, which is 3 times 3, and that's 2 times 3. So my prime numbers are here. I got a pair of 3's come out, and I got a pair of 2's that came out. So whatever's on the comes out, we multiply it. 2 times 6. 2 times 3 is 6. And we had a 3 left over, stays in. And my r's, r to the 18. So 18 divided by 2 is 9 with no remainder. And then s's, we had s to the 13. So 13 divided by 2 is 6 with a remainder of 1. Okay? Let's check our answer. 6R9 S6 squared times 3S. So this is 36 R18 S12 times 3S. So 36 times 3 is 108. And R, there's only that one, 18. And S, 12 plus 1 is 13. So that matches this. So that means our answer is correct. So this answer is good. Okay. Let's see. 22. Okay, 63 is 3 times 21, which is 3 times 7. So my prime factorization, I got a pair of 3's comes out. So a pair of 3's come out, and 7 stays home. Now my variables, x to the 5th. So 5 divided by 2 is 2, with a remainder, goes in the house, a remainder of 1. And my y's, 25 divided by 2 is 12, with a remainder in the house of 1. And z's, 14 divided by 2 is 7, with no remainder. So that's our answer, but let's check it. So this would be, on the outside, we have this. So let's square it, times our inside. So this 3 squared would be 9. X squared squared would be x4. Y12 squared would be y24. And z to the 7th squared would be z14. We're going to multiply that by 7xy. 9 times 7, 63. X to the 4th times x, invisible 1, is x of 5. Y to the 24 times y1 is y25. And then put your z14. So that matches. So our answer is correct. And leave one more. $3.92. So let's do 2 times 196. And then 2 times 98, which is 2 times 49. And we know that's a perfect square, 7 times 7. So there's all our prime factorization. Make sure you get all your prime numbers. A pair of 7's come out, and a pair of 2's come out, and this little lonely 2 stayed home. Okay, so 7 times 2 is 14. Now my variables, a squared, 2 divided by 2 is 1. B squared, B1. C cubed, and you got 1 with 1 left over. Let's check our answer. 14ABC squared times 2C. So 14 squared is, what, 1C, 196. And then ABC squared, A squared, B squared, C squared, times 2C. So 196 times 2 is 392. A squared, B squared, C squared times C is C cubed. That matches, so we're good. okay? All right, my hand has gone to sleep. All right, practice, do your practice and upload it onto Google Classroom and practice these, okay? Let's see, Wednesday, we do study guide. Thursday will be a test. The test will cover all the exponent rules. It'll cover exponential equations, graphing it, writing an equation from context from a word problem, then writing an equation from a table, and then scientific notation and radicals. Okay, so y'all start reviewing now. All right. All right, y'all have a good evening.